Hello friends, welcome to the channel Simplify Maths. Today we are going to learn about highest common factor called HCF. Before discussing the HCF of two or more numbers, we are going to discuss about what are the prime and composite numbers. So all the numbers we can say we have numbers from 1, 2, 3, 4, 5, 6, 7, 8 onwards. These all are natural numbers starting from 1 to infinite, and these all numbers can be categorized into two categories. One is the prime numbers and one is the composite numbers. So when we say what are the prime numbers, so the definition of prime numbers are those numbers which can only be divided by a number 1 or the number itself. So examples of prime numbers are 2, 3, 5, 7, 11, 13, 17 onwards. So you can see here the number 2, it can only be divided by number 1 or itself. Similarly, number 3 can only be divided by number 1 or itself, and same is for the other numbers like 5, 7, 11 onwards. And when we say what are the composite numbers, so in the above set all the numbers apart from the prime numbers are composite numbers. So for example, you have 4, you have 6, you have 8, you have 9, 10, 12, 14, 15, 16 onwards. So when you say number 4, it can be divided by 1, can be divided by 2, can be divided by itself 4. And same way 6, it can be divided by 1, by 2, 3 and itself. Same way 8, it can be divided by 1, 2, 4 or 8. So now you can see here these numbers can be divided further by any number apart from 1 or themselves. So due to this property they are called composite numbers. So we will discuss a term called factorization. So what do you mean by factorization? So when we have a composite number, for example 12, we can say it can be divided by 1, 2, 3, 4, 6 and 12 itself. So how we can write 12? 12 can be written as 1 into 12, or it can be written as 2 into 6, can be written as 3 into 4, can be written as 6 into 2 or 12 into 1. So basically what I'm saying is this composite number we can write it as a multiple of 2 or more numbers maybe, and these are called factors of 12. So basically if we take another example, say 24, we can write it as 2 into 12 or 1 into 24 obviously, or we can write 3 into 8, we can write it as 4 into 6, and we can also write write it as 1 into 24 itself. Sorry, that is already written. So these all are examples of the factorization of a composite number. So now if we further discuss factorization, we have a term called prime factorization. So when we discuss 24, we could write it as 1 into 24, or we could write it as 2 into 12, or 3 into 8, or 4 into 6. right? So now in this case, when we wrote 24 as 1 into 24 or 2 into 12, if you clearly see 24 or here 12 or 8 or 4 or 6, these are further a composite number. So if we take example of these 3, we can further write it as 2, and this 12 we can further divide into 2 into 6, and in this case 2 and 2 are prime numbers, and this 6 is still a composite number. We can further divide it as 2 into 2 into 2 into 3. So we will keep dividing it by factorization until we are left with no factor which is a composite number. So you see here, these all factors are prime factors. Same way, this can be further divided into smaller numbers which are prime numbers actually. So if we take example of say 15, let's take 45, we can write it as 5 into 9, and in this 9 is a composite number. We can further divide it as 5 into 3 into 3. So these all are prime numbers. So when we talk about factorization and we create the factors of a composite number, and we narrow down to those factors which are actually prime factors, this process is called prime factorization. So now we will discuss our topic, which is the highest common factor, or HCF we call it as. So now if we take example of two numbers, say 12 and 18, these are two numbers. So 12 we can write it as 1 into 12 or 2 into 6, or we can write it as 3 into 4. And for 18 we can write it as 1 into 18, or we can write it as 2 into 9, or we can write it as 3 into 6. So in this case, the factors of 12 can be 1, which can divide 12, or it can be 2, it can be 3, it can be 4, it can be 6, it can be 12 itself. And same way for 18, its factors can be 1, which can divide 18, or it can be 2, it can be 3, it can be 6, it can be 9, and it can be 18 itself. So these are the factors of number 18, which was a composite number, and these are the factors of a composite number 12. So what is HCF? HCF is the highest common factor. So when we say highest, and that is common between these two, so we see 1 is common, but this is not the highest. 2 is common, it's not the highest. And then we have 3 is common, but this is not the highest, because we have 6 present in both. So 6 is common and it is the highest. So HCF of 12 and 18 is 6. So this is how we define the HCF and find it. So you saw like how we can find the HCF of two numbers, but this kind of method becomes a bit difficult when we have those two numbers as large numbers, or they are more than two numbers. So we have different methods to find the HCF. So one of the method is finding the HCF using prime factorization. So we discussed prime factorization earlier. So let's discuss how to find HCF using the prime factorization method. So let's take two numbers, 4 and 6. So here what we will see, 4 we will find its prime factors, so it can be written as 2 into 2. So these both are now prime numbers. There's no composite number left, so we will stop here. And for 6 we can write it as 2 into 3. So both are prime numbers. So in these both cases we will find what are the maximum prime numbers which are common between these two numbers factors. So you can see here 1 2 from 4, another 2 from 6, this is common, and there is no other prime factor left which is common. So HCF of 4 and 6 is 2. Let's take another example of bigger numbers, for example 24 and 36. So 24, if we find prime factors of it, we can say it's 2 into 12, then we can further divide 2 into 2 into 6, we can further divide 2 into 2 into 2 into 3. So these are the factors of 12. Similarly for 36, we can write it as 2 into 18, which is 2 into 2 into 9, or 2 into 2 into 2, 3 into 3. So these are the prime factors of 36. So now we will find all the common prime factors. So there is 1 2, there is another 2, we write it here. There is another 2 here, another 2 here, we write it here. There is no further 2 here, but there is a 3 which is common, we write it here. So whatever common prime numbers we found, we multiply them all together and this becomes 12. So 12 is the HCF of 24 and 36. So this is a way to find the HCF of two bigger numbers. Let's take an example of 3 numbers. So when we write 144, it can be written as 2 into 72, or 2 into 2 into 36, or 2 into 2 into 2 into 18, or 2 into 2 into 2 into 2 into 9, and which is written as 2 into 2 into 2 into 2 into 3 and 3. So these are the prime factors of 144. For 192, we write it as 2 into 96, 48, 24, 12, 6, 6. So these are the factors of 192. So when we have 180, we can write it as 2 into 90, or 2 into 2 into 45, or 2 into 2 into 3 into 15, or 2 into 2 into 3 into 3 into 5. So now we have, these are the prime factors of 144, these are the prime factors of 192, and these are the prime factors of 180. So now we want to find the HCF of all these 3 numbers. Let's find what are the common factors which are prime in these 3. So we have a 2 here, we have a 2 here, and we have a 2 here, we write it here. Then we have another 2 here, here and here, we write it as here. Then we have, there's no further 2 available, then we have a 3 here and 3 here. So now you see there's no more 3 which is common, and there's no 5 available. So this is the number which is 2 into 2 into 3 is 12. So 12 is the HCF of 144, 192 and 180. So this is the concept of prime factorization method to find the HCF. So now we will discuss about the HCF using the continued division method. So this is another method to find the HCF of two numbers. So we will discuss the same example we took earlier, 24 and 36. We want to find the HCF of these two numbers using the continued division method. So how it works is, you take the two numbers and out of that the bigger number you put inside, like you divide, and keep the smaller number outside, and you divide it here. So when we say divide here, so basically we say 24 ones are 24 and we are left with 12. This is the remainder. Now remainder is the next number which we will use to divide the smaller number. So we bring 24 here and divide 24 by 12, and we keep doing this until we are left with 0 balance or remainder. So 12 2s are 24 and we are left with 0. So in this case, once we get a 0 remainder, at that time the divider is the HCF. So this is the continued division method to find the HCF. So if we use the similar method to find the HCF of the earlier example, which was 144, 192 and 180. So how it works is, when we have three numbers, we take two of them, use them to find the same method to find the HCF, and once we have the HCF, we use that HCF to find the HCF between that HCF and the third number. So here we take this and this, so we bring 192 inside, 180 is outside. So if we take 180 into 1, it is 180, and the balance is 2 and 1, so 12, and we bring 180 inside, because the smaller number becomes the number inside the bracket to be divided by the remainder. So now we see, we can say, if we multiply 15 by 12, we get 0 balance. So in this case, for 192 and 180, the HCF is 12. Now the next step will be find the HCF of this HCF and the third number, which was 144. So here the bigger is 144 and divider is 12. So when we calculate, 12 into 12 is 144. So remainder is 0. So this HCF of all three is 12. So this is the way we find the HCF of two or more numbers using the continued division method. So another way to find HCF for larger numbers. So we saw like prime factorization, and we also saw the continued division method, and they can easily find the HCF of two or more numbers. But as the number are larger, becomes larger, or the number of numbers from which we want to find the HCF become higher, that method becomes a bit difficult. So in that case, we want to have another method. This is called like the HCF for larger numbers. We can find in another way. Basically, so we take the earlier example. We want to find the HCF of 24 and 36, for example. So in this method what we do is we keep these both numbers like this, and we divide them with the common prime number. So you can clearly see, first you can divide it by 2, and then we again divide it by 2. Now we cannot divide it by 2 further, but we can divide it by 3. And now we cannot further divide by any common number because 2 and 3 is themselves prime numbers. So in this case, whatever common numbers we had as prime numbers which we used to divide them, they are part of the HCF. So HCF is 2 into 2 into 3, which is 12. So same way, if we want to find the HCF of the earlier example, which was 144, 192 and 180. So in this case what we will do is write all the three together. Now divide it with the common prime numbers. So start with 2, divide it, we get these numbers. We further divide by 2, we get this. Now we cannot divide all 3 by 2. We can see the next prime number, which is 3. We can divide them by 3. So this becomes 12, this becomes 16, this becomes 15. So now you see here there is no further common prime factor because we cannot use 3 and we cannot use 4 or 5 or 7 or 9 or 7 or 11 and onwards. So these are the 3 common prime factors we found. So this is how easily we can find the HCF of these 3 numbers by this method, and this is 12. So let's take another example. We are taking 3 large numbers here. So in the same way we write them all together: 624, 936, 264. So first divide by 2. So this is 312, 468. So we can further divide by 2. So this is 156. Sorry. So now we can further divide by 2. This is 78, 117 and 33. And we cannot further divide by 2, so let's try with 3. So you can see here. So now let's try with 3. We cannot divide by 3 further, right? So because 11 itself is a prime number here. So clearly we cannot divide these numbers further. So the HCF is 2 into 2 into 2 into 3 from this all the prime factors. So this is 24. So you can clearly see here, using this method you can find the HCF of larger numbers or more than 2 numbers in a better way, an easier way, as compared to the prime factorization method or the continued division method. I hope you like this video. I request you to subscribe this channel and press the bell icon if you like this video. This really helps. Thank you.